Yeah.
Okay. Okay, thanks all of you for coming here. Stay in this room, not go outside for the nice weather. Appreciate that. So today our speaker is Lisa Shala, and she actually has supported soldiers and the Army with technology for more than 20 years. She led Army Intel with big data technology efforts, including analytics, cloud computing, and cyber security. She's currently at the Army G8 program analysis and evaluation director. She focused on data migration to the cloud and the Army G8 data science pilot. She earned a master's degree from MIT and National Defense University and Virginia Tech. So her research interests include computational social science, and complexity studies. So let's welcome Lisa.
Thank you. Thank you, everybody. I'm extremely pleased that you're all here because it's such a gorgeous day outside on this beautiful campus. So thanks for being here. And thanks to our online teammates who are dialing in at some later time. I'm here from the Army, and I'm here to share some of the information about what we do. We were talking in a series of very interesting conversations this morning, and one of our data science operational research system analysis people who are in the field right now is Brigadier General Richard Kim, who's helping lead the humanitarian disaster recovery operations in Puerto Rico. So when the Army is investing a one-star general, not just in helping their friends and neighbors, but in learning about operations research and data science, that tells you that there's depth and breadth of our interest in our experience base. So my talk is in three basic parts. I'm going to talk about what I do at the enterprise level. I work at the Pentagon at the corporate part of the Army. And in that we manage a special group of people, which are Operations Research Systems Analysis, which we call ORSAs. And we'll talk about them. Then I'll pivot to the humanitarian disaster recovery operations that we do, because in addition to all the things that you do and you plan to do, we do things that we don't plan to do to help our friends and neighbors. So we have those activities. And then the third part of my talk, I'll talk, hey, welcome aboard, come on in. I'll talk about how we're looking at our ORSA officers and our data scientists and how I'd like you to think about some of the focus areas to be good practitioners of this domain. As we've seen with many data scientists, it's easy to get things wrong quickly and at scale if you don't have the thoughtfulness about what you're doing. So that's the place we are. So at the top, just being part of the big Army leadership at the Pentagon. The bottom, some of the disasters that we were doing before we got involved right now, which are some of the earthquake rescues, the hurricane relief in various locations, and then the Texas flood response. But we have soldiers out there on point fighting our nation's war, but also helping their friends and neighbors at home. Okay, so what is my organization about? We have focus areas. We program, which is not the same as computer programming. We do the analysis to program a long-term budget. For us, that's that 5-year program that says, Congress, if you give us the following millions of dollars, we will do the following things you've asked us to do. So somebody's got to do the detailed analysis from that little soldier in formation up to big organizations at high levels to go do things. So that's that programming element. Then we manage our data. We have very large authoritative data sets, and so we have analytic tools and techniques to manage those systems. Then we have our Operations Research Systems Analysis cohort of Army officers. It's about 750 of them that are directly involved in that cohort, and we have civilian counterparts that also do the analytic work. So all told in the Army, we have more than 22,000 people who are involved in various levels of analysis that are relevant to this, that could benefit as domain partners shaping our data science or could do the data science. So we'll talk about that continuum of people. And then getting the data science capabilities into our organization, we've done a data science pilot on Amazon Cloud for us, both to grow the data science community and to grow to the cloud with our IT infrastructure. So I'll talk about that. Okay, so what's the deal about data? When we think about data, We think about lots of data from many sources, many different types, that's available to be accessed but needs different kinds of analytic techniques to do it. So we think about our program data. We think those are lots and lots of structures, force structures of manpower and equipment that cost certain amounts of money to operate, come on in, to operate in certain parts of the world over the next 5 years. We think about our training data. We have Abrams tanks. They're here in formations and around the world, and we actually deployed some Abrams tanks to support one of our alliances in Poland, right? You can read about it in the papers. And so there are things that happen when you take a tank or a helicopter where you need a lot of people and a lot of spare parts and a lot of support in terms of fuel and all the other supports that are required. So just because you see a tank doesn't mean that's the end of what the iceberg looks like. There's a lot of other enabling capabilities and people who make that work. Then we have reports with our Bradleys and our helicopters that are fighting or supporting with our Abrams. We have imagery. You see the soldier holding a micro satellite or a micro drone that can take pictures. So if you think about the humanitarian response opportunities, you want one of those soldiers with one of those little drones looking over, could be Texas, could be Florida, could be the islands where we have people doing support, to know what's the condition on the ground. Not from that giant satellite in the sky that takes a picture of the whole United States, but in the next neighborhood over, how are the ground conditions? Do people's houses still have roofs? Do we still have roads that we can walk across? Do we suddenly have a gap between one part of the neighborhood and another part where the water just made a new river between A and B? So that kind of satellite imagery that has its origin in our warfighting functions has benefits to our helping our friends and neighbors do humanitarian recovery. The geotag data, same situation. We started with being able to know where things were on the ground based on satellites tagging them, right? Because we had a military. It turns out it's socially very useful, whether you're helping someone be recovered in humanitarian response or whether you're trying to navigate around this campus, which is a lot of one-way roads, right? I want my GPS signal to send to my smartphone where I can go ahead and find out where I need to be. I turn left at the next light, go forward 900 feet, it'll be on my right-hand side, park, all good, right? So something that started as a capability that came out of the military is available for our civilian ingenuity to figure out how do you want to exploit that data and how can I provide that as a service to people who need to use it. We think of our sensor data. Internet of Things is very trendy. We think of analytics to do analysis of audio and video and just the messages people, you, me, and everybody in this room makes when they're sending phones, right? So some of these things, like these kind of numbers in spreadsheets, those are structured data, easily understood. We kind of know where we get the data. We can curate them and have data quality metrics and do statistical analysis very nicely. When we think of the more unstructured data around the edges, it's a different world. So different kinds of graph analytics, we were talking about those a lot, and different techniques can help you understand if I have a gap in audio, such as the phone companies have been working on for many, many decades. How do I fill in that gap with an expected value? But if I have a gap in a series of data, for example, we were talking about pharmaceutical trials this morning, if I have somebody who dropped out of a trial, what do I do with a gap in the data for the next time I want to assess them? Do I carry last measure forward, or do I stop them and have a hole, or do I eliminate them from the data set altogether? Different ways of dealing with data gaps apply for different domains and different contexts. So then, what are our challenges? These are the challenges we thought we would have when we were planning for a nice, effective year. We thought we'd need to build the Army's 5-year plan. We thought we needed to migrate to a new data center. Moving from on-premises data center as an information technology exercise to using a cloud infrastructure is not easy. If you've ever done IT at the enterprise level, people start to be very fearful about that, and there's a lot of complexities to it, and we have to move. We're being directed to do so. We also want to have better data security. Our community is very strongly affected in a negative way with these data breaches. We had the Office of Personnel Management lose a lot of our data. And then the Equifax breach that we just heard about most recently has people paying attention, but data security is a problem every day. And it's a problem that can get worse if you don't know about it, but can cause people to panic if they do know about it. So there's a good practice part of this, and there's an emergency response part of the data breaches that we need to be aware of. We also need to support our analysts. Our analysts are in every organization around the world, right? And so we have folks who are really paying attention to disaster relief in various locations here in the continental United States, and we have people who are supporting our allies in Korea who are concerned about the fight tonight requirement, right? If your next door neighbor is shooting missiles over your allied land where you are standing, you have a problem. You have an organizational problem, you have an analytic problem, you have a trying to discern the intentions problem, but it's a problem, right? It's not what you thought you were there to do, but it is what you are doing now, right? So we have to support our analysts whether they're doing what they plan to do or if they're also dealing with these emerging needs. And then we want to collaborate with data science overall. So with these 4 big requirements this year, our answer was, hey, let's do a 5th big requirement. Let's pilot data science for our ORSA officers using Amazon. Nothing like a new hill to climb. It's a good thing. So what's the world that we're talking about in terms of data? If you think about data, really, really big data is over on the far end of the spectrum. That's over here. And for us, that's the world of cyber data and intelligence data. And our battlefield intelligence data includes sensors. So that person that had a little micro drone with sensor data, if you take pictures in the sky, you have to land them on a data platform. And then you need to do analysis. And it's usually not enough to analyze the feed that you got from the drone. You have to link it to other data sets. So this multidimensional, multi-data set analysis approach is really important to be good at. It's really hard to be good at. And it's really hard to understand what assumptions you have built into your process. So we had, again, great conversations this morning. I think that practitioner basis is going to be really important. We also have long-term, 50 plus years of operations research planning and programming, right? We know how to do plans. We're good at it, right? We practice. That can fit in a spreadsheet. You can manage a few attributes. You simplify the problem. You say, go take that hill. You say, send the helicopters over here to pick up these people. It's easy until you start adding more data, until you get data from somebody else that's a different source than you usually deal with. When we're partnering with FEMA or we're partnering with somebody who's on the ground, like the Cajun Navy teammates who are volunteers who are helping their neighbors, fantastic, right? But how do we bring that data together? How do we communicate with them in a timely and really effective manner? I don't want efficiency as much as I want effectiveness, right? I want to get things done to make the situation better where we are. So that's that world. And then we have this interesting world of systems analysis where we have pretty giant data sets about very specific events. So some of the techniques that work in that, there's a lot of attributes, but it's kind of between spreadsheet and big size data, right? It's moving just outside the bounds of a conventional data center or conventional data system. That's where this world where we're working in now is this data science pilot. It's in the middle between spreadsheet and big. It's in the middle between a few attributes and a lot of attributes. And one of the areas we're moving into is this Internet of Things sensor data. And for us, a good example you've seen in the commercials by General Electric. They talk about taking the data off of their helicopter engines and having 1.5 terabytes of data after a 3-hour mission. And somebody's got to do analysis on that. That is a rich source of data to be mined, not just on the one incident basis, but on the historic basis, right? So great, we can create and collect lots of data. What do we do with it? How do we get the goodness out of it, right? So that's a very rich area, and I think that we're all going to be interested in that for years to come. So who do we have? We have the ORSA officers that I was talking about. And who are they? They're high potential, mid-career people and higher who advise commanders and organizations on how to do good analysis and good evaluation, right? A and E. We think about how do we professionally educate them. They come for research-focused master's and PhD degrees, which is pretty phenomenal, at a variety of schools. Can I point you out, Greg? So Greg Burton is one of those high potential officers who is a reservist who's here in this course. He's not an ORSA yet, but he's an example of that smart Army officer who's worked in those different Army domains and can learn these skills and apply them as a reservist to military experiences and to civilian experiences both. It's an exciting opportunity space. We're glad you're here. So we also teach tradecraft and analytic approach to our ORSA officers in the classroom. We give them additional training in schools around the U.S., in classroom and online, in data science specific schools, the same kind of tools that you all are looking to use like R, Python, that sort of thing, the same kind of techniques that you're working on. So we've got a community that's very, very interested in becoming adept at these skills. We partner training with industry. 4 of our most popular training with industry opportunities are Digital Globe, who do the maps that you're seeing and we're all paying attention to. Amazon is a new opportunity. IBM, of course, the Watson team, but also their professional analysis groups. And Verizon, who thinks a lot about cyber and network data. So there's more than 116 current opportunities for training with industry with our teammates, but that's the kind of experience in a broadening sense that we give to our team. Now, we talked about the Data Science Consulting Club opportunities today and how the students who are involved with that here are expanding their connections to other partners and applying some of the skills to real-world problems and working with real domain experts. I'm excited to see that. I think that's very good stuff. And so I think it's important to have high-quality relationships, not just quick projects, thank you for helping with my research, I'm on, but how can you think of having that professional community grow with you and you grow with it? Hi, come on board. So we're interested in that diversification for our team. So that's how our ORSA officers fit in. So how do we think about our teaming? For us, I'm going to start in the center, right? We think about data science as the nexus of mathematics and statistics, which is our, you can have these, which is the basis of our ORSA officers for all these years. We start with people who are very strongly founded in statistics and some of the mathematical arts and sciences. So we then have some computer science expertise. We have some people who are extremely, extremely gifted at computer science, and we use some of those folks for our big data analytics, especially in the cyber arena right now. That's turning out to be very challenging. It's challenging because an algorithm that works perfectly against a training set of something as small as 10,000 records starts to be very wrong. Come on in. Starts to be very wrong at scale with 1 million records or 500 million records, right? So the things that you think you know at small scale may not prove to be the case when you get large scale. It's an interesting opportunity and problem. But the reason we put our domain expertise in operations and intel at the top is that in our community, in the Army, we require knowledge of how the Army works, right? You think you know how the Army works if you watch, we were talking about some of the fascinating TV shows that are on right now that are really compelling, right? But if you haven't walked 25 miles with a rucksack on your back, you don't know what it's like to walk 25 miles with a rucksack on your back. If you haven't jumped out of a perfectly good plane, which I totally recommend, you don't know what it's like, right? There is value to the experience. And it's something that I can't tell you about. I can recommend it. I can say, hey, if you're interested in working with the military, you can either work with the military directly or you can partner with some of these disaster recovery operations. We were talking about some of the FEMA connections or the emergency medical technician opportunities. There's ways to team with people to get that operational flavor. But you really need to talk, come on in, you really need to talk with and work with and respect the opinions of those daily domain practitioners. They know things they can't tell you that they know, but they know that if you tell them I have a black box answer, they're going to say that is a solution that can't work. May not be able to tell you precisely why, but they know. They have tacit knowledge, they have techniques, they have ways of understanding. They know when they look at a data set, which data should you omit or exclude or ignore for certain periods of time, right? If you're looking at, we were talking about this, the social media data mining projects. If you're looking at Twitter feeds from South Florida before, during, and after their recent hurricane response, you will get the people who tweet. You will not get the people who don't tweet. You will not get the people who don't have power either to their handheld phone or to the cell tower. They can't tweet. They won't tweet, right? So if you're listening intently to this community, you won't know the context that a domain expert can help you understand, right? There may be a really good person on the ground with one of our partner organizations who's collecting data in a really structured way, and you get a really solid stream of data for a certain amount of time because there was a lot of tradecraft and a lot of thoughtfulness and a lot of thoroughness involved in that data collection. You, looking at the raw data later, don't know where it was good. You don't know where it was bad. You don't know where the transition points were. So you need the domain expertise, right? That's crucial to us. We think about the skills we're bringing, domain expertise. We're thinking about the math and stats, which includes how to use machine learning responsibly, right? Deep learning is interesting, but if you learn that all Nobel Prize winners come from places where chocolate is also very popular, and you do a correlation between those two pieces of information, you could be wrong fast at scale, right? But if we think about how to partner in this way with the data, grounded in our data, right? We have a lot of data that you just don't see other places, right? Our data is messy, our data is collected from a lot of people, we share data with a lot of partners, it's a different security classifications. It's really a complicated and wonderful space to be in, but it's not easy, right? So, and what do we do with data? We're not just studying it for the sake of study. Come on in. We want to operationalize that data for decision makers. So if I need to make a decision, if I am General Kim on the ground in Puerto Rico, and you want to do a terrific data analysis and you give it to him in a week and a half, he may be impressed with your data analysis, but it doesn't solve the problem this morning, this afternoon, tonight, right? So timeliness is a really important piece of data. Understanding how do I handle uncertainty and how do I incorporate new data, right? Something that might make me change my analysis, change my understanding of the situation. Those are all really important tradecraft parts of this equation. And then the last thing we do is we think about the functions. Our pyramid goes from the bottom where everybody's included to fewer people in the middle to the top people is very few. But we have a very large community that performs analysis. They use all kinds of tools and techniques and problem-solving ways. And a few of them make tools, right? Whether it's a report, a data visualization, an analysis, a drill down, whatever they're doing. And then fewer still create algorithms. But we want the people who are creating algorithms tightly tied into the people who are doing the analysis, right? People who have really dug into the problem and who will use the tools are hugely valuable to coming up with better approaches and better tools and better ways of combining data. So, Data Science Pilot, Amazon. Our goal on this is to give our ORSA officers and the analysts in the Army more tools at the point of need. And we do it on the unclassified side so we can pilot a lot of things, and then we promote it into our business operations further up the chain. So we're starting with the cloud. We add R and Shiny, which allows you to create web applications. We are experimenting with Tableau as well as other data visualization tools. Tableau is one of many. We have Python as a scripting language, which is harder than you think to get permission because it is in fact the opportunity to create tools that you can take down your network. Come on in. So we want to be careful out there, right? And then we're experimenting with some of the services that Amazon offers. Lambda lets us do some really nice machine learning at scale, right? And so this is not just let's use the tools, but let's learn about how to use those tools in our enterprise, which is cost constrained. If you want to do a Monte Carlo simulation and use up all my compute cycles on my Amazon cloud, you could, but you may not, right? So we have to have some ways of checking before we spend up all of our resources. That's one of those challenges of being an organization with a budget and a mission that's really interesting, challenging, and has to deal with these unforeseen events. So how do we build community? This is Melanie Vinton, who's a lieutenant colonel. She's talking to a community of people at our Army Research Lab in just one of the many data science meetups that they have. These are our scientists and engineers who spend their lives thinking about Army problems. And that's just one of the communities that's involved in this. So they were talking about a big data topic in December. They've done a Python one since. They've done a lot of discussion about Hadoop analytics and big data analytics because we use Hadoop, right? Well, Hadoop is hard and easy to use depending on what you're doing with it. It doesn't fit everything, right? Not everything is a sparse matrix. Not everything is a relational database. There are a portfolio of things that we need to do. We have a data science center of education where our ORSs share lessons learned and solve problems together on the unclassified side with each other so that they can use them in a variety of domains. It's useful to understand the techniques, like you all are, of data science as applied to a well-known problem with a well-understood data set, and then be able to extend those, understanding the new context, to the new parts. And then we have analytic activities. We have our training and doctrine command one. We have the Army Materials Support analytic activity, and then we have Center for Army Analysis. So we have big analytic activities. We like data science. Okay, so what are the challenges for cloud migration as a IT paradigm shift? It's brand new for most people. It's not brand new in the commercial sector. It's been around for a decade or more. But when you take enterprise activities that are used to being the traditional relational databases that are older probably than all of us, right? And move them to new structures from a compute paradigm, new business models, people have to do some transitioning, and it's hard. And when we add the challenge and requirement to have cybersecurity for our data, much better than Experian recently demonstrated, but a lot of people have a lot of data problems, right? We need to make sure that we are good about protecting our data and sharing it with the people who need to see it and not sharing it with the other people, right? So we think about services. There's a new service model. This is really interesting for enterprise IT managers who are trying to figure out what the new service models mean. But I have to contract separately for my infrastructure and my cybersecurity provider and my extension cord, as we call it, of the network, which is the cloud access point, and then the individual assessor who will make sure I met the requirements, who we call a security control assessor team. We have one of those exciting teams coming to my organization on Monday, and we're thrilled. We are really thrilled. We have been training and practicing and getting everything configured to be ready to go for that big final exam on this particular part of our project, so it's exciting. But the skills are different, right? So as you bring new skills to the organization you're working with, whether through the data science consulting or through your next job or as you go back to your organization if you're currently working with them, you need to do the bridge to show people that you're working with, this is what you've been doing, this is what I want to bring to advance what we're solving in terms of problems, and here's how you correlate those, and here's what would work well in terms of what it could apply, and here are the assumptions that could make this not work for what we want to do, right? So there's a translation. If you make it through this, and most people do, and some people don't, but if you make it through, it turns out to be very generative. It makes you able to solve problems you couldn't solve before or see opportunities that were hard to get to earlier. So it's pretty exciting. And so what kind of data science analytics are we focused on? There's kind of a classic in the business domain set of analytics where people talk about descriptive, diagnostic, predictive, and prescriptive, right? Descriptive says, what are you doing, right? How do I know what I'm doing right now? Diagnostic, what worked, what didn't work, and why. Predictive, what do I think is going to happen for us when we think about our population flows of recruits who will successfully make it through summer training, right? We just had people who went through basic training. How many of them are going to make it? Who's a good candidate to come out? How can we help people to help them be more successful? That's that predictive plus diagnostic piece. And then the prescriptive, how can I shape my organizational experiences to help people be more successful? With my recruiting, if I have people who want to join the Army and be soldiers, how can I help them understand and train up themselves to get physically fit so that when they go to basic training or they go to basic parachute school afterwards, they're physically ready and they won't get hurt, right? We want to keep our people strong and moving forward and gaining those skills. So those kind of analytics are really well understood. Lot of new ways of visualizing the data that we analyze. Hey, welcome. But then there's this other category. That's over here, right? This is the context focused. And it's really important to think about those as being different. These descriptive, diagnostic, predictive, and prescriptive analytics can work well with structured data. When we think about context-based, we think about entities and events. We think graph analytics and other kind of relationship-based analytics. We think behavioral analytics. Those are not the same as this other kind. And so we understand that they have difficulty and they have context-specific and they can be generally lumped together with the other ones, but there's something different about those. And so it's important to know the techniques that you're using for one kind of category on this scale are a little different than the ones on the other side. So what are we doing? We're going to protect and use our data. We're going to simplify our operations. We're going to make it easier to do the nuts and bolts of our job so we can do more interesting data science, data analysis, and problem solving with our leaders. We're going to do big data analytic tools and a toolbox strategy where we're not married to one solution. We're not people with one hammer for all the nails in the world. We're people who understand that there's lots of techniques and approaches that could help us solve problems. And we have interesting problems to solve. And we're going to leverage our data science capabilities. So that's the enterprise part of what we're doing. You okay? And then how things will evolve. We'll have more services on Amazon. We'll disaggregate services that use our cybersecurity model. We'll expand our data science. And we'll make more data-informed choices. But suddenly on the way to work, things change. And so the Army is so involved in humanitarian disaster relief that this is our webpage. And we have a menu of things that we respond to, whether it's earthquakes, explosions, floods, hurricanes, medical emergencies, snowstorms, tornadoes, tsunamis, or wildfires, right? So we do a lot. We do the things we plan to do, and then we help our friends and neighbors and fellow citizens all the time. So what's that look like? This is an Oregon National Guard soldier fighting wildfires, right? And we have wildfires in the West, even now, this late in the season. So we need to respond with agility, with really rapid systems analysis and rapid understanding of how things interact. We talked to Professor David Wild about some of the exciting research being done to think about how do you do that disaster synchronization for those response people. But we also talked about some of the really simple ways to either produce or consume or both different data visualizations. On the right-hand side, there's a simple way from InstaWeb, which is the incident response website, to show how there are a number of activities involving wildfires in the Denver area in Colorado. And so big ones are bad, little ones are not necessarily less bad, but they're less space. And big ones that are inactive may need to become reactive again if Mother Nature decides that the wildfire is not done, right? So keeping track of these things and providing this information to citizens who need to avoid those areas, to emergency responders who want to go to those areas, to different parts of the emergency response team, that's an important skill and capability that we need to collectively all practice. We think about humanitarian disaster relief affecting the way we think about our systems. In the upper right over here, we have this beautiful model of a Humvee from a German partner firm, and it's really clean, it's shiny, it's pretty, And then we put our Humvees into the water down in fighting the floods in Houston, right? If you're this guy or this team that's in the Humvee today, do you think your Humvee is going to be able to ford that water when it's that tall? You don't know. But if you're a designer or a system analysis or an engineer thinking about Humvees, boy, that's a good lesson. How are we planned it for one thing, how are we really using it? If we've got the trucks, this is a 5-ton truck with, again, some Texas National Guard emergency responders, they're helping some folks who got stuck in the water. The water's up almost to some people's waists, depending on how tall you are, right? So how do I respond to people who are not soldiers, who are not trained in using and getting on military vehicles and getting off? How do I think about how to help the civilians who need to be able to get into the truck, climb on board, get some food, get some water, get taken to somewhere a little bit safer? And okay, this is a nice, healthy person who can climb. What if it's grandma or grandpa, right? Or somebody who needs help getting in, right? So thinking of how our real usage scenarios affect our design parameters is another use of our data science analysis portfolio. Here we have really interesting insights in how we consume and produce analytics. This is a lot of the consuming analytics around the flood. And so we had Digital Globe satellite images way before in 2016 in November and after on August 30th, 2017, where the land that was is now different because of the flood, right? So how do you understand and exploit this as a new data source, right? That's an exciting space, right? This is a really interesting set of analytics from the Washington Post. And thinking of how do you share data science with people who are not data scientists? How do you share analytics really in a really user-focused way? This particular flood map, you can click on the river that you care about and see where it was between August 24th and August 31st. Because if the river is taller than the banks, the river will overflow the banks, right? So, and rivers don't stop being full when the rain stops, because remember, the rain upstream fills your river downstream. And so it's really useful to think of how do I share and communicate my analysis in a way that other people can consume it, right? Really some outstanding data science work in the public media space during this set of disasters, and we're real happy to see it. We're real happy to share what we have with them. So being savvy users, again, this is bottom right-hand side is disaster relief, and then that map or the image is turned into a map of how much damage or destruction affects those particular buildings in that location, right? So how do you take a satellite image, which a lot of people don't know how to understand, and turn it into something, oh, your buildings are red. You needed more help than the guy whose buildings are yellow, right? If I'm doing disaster response, this neighborhood, which is in the red zone, needs help first before this neighborhood, which is in the yellow zone. But who am I going to hear from on the phone, on Facebook, on Twitter, or however else they're reaching out? I'm going to hear from the guys in yellow, right? They were damaged less. Their cell phones work, so they can get on the phone and start saying, please help me faster. The people in red need help more, but they can't tell me about it. So, okay, so let's talk about the challenge of disaster recovery. If I send somebody to help you, I have to have the ability to support not just you, the person I'm trying to help, but the helpers. I need a place for them to sleep. I need food and water for them. And I need to be able to talk to them to know how they're doing. So it's not easy to go from big, giant disaster relief, pushing airplanes full of supplies into an airport, to going from the airport to that last mile on the ground. And this kind of diagram tells us why it's hard to be aware of that. So how do you do? Be a good producer of data. Think about using analytic frameworks that work for each domain, defining your assumptions, use good tradecraft, like appropriate statistical techniques. If you overfit a curve and get rid of all the outliers, you will not see anybody in the red on the map, right? If you don't understand the assumption, I didn't hear from this person, therefore they're okay, you will you will not recognize the reality that you won't hear from people who need the help most because they can't tell you, right? So evaluate output, always correlation does not equal causation. There's a bunch of other good analytic approaches there. And the validation with your domain experts really matters. So our analytic frameworks vary by the domains. There's a bunch of them. You just have to get with your domain experts who are operational, who don't talk data science but do talk that domain, and partner well. And we talked about different time periods having different precision and accuracy. So share your assumptions early and often, right? Team for success, ask your domain experts for help. So really one of the key areas of focus, now that we've talked about helping people, now we've talked about our enterprise approach to data science, let's talk about how you can be good data scientists. Thinking about focusing on your ethics use, your privacy perspective, doing behavioral analysis well, and doing more, right? So be ethical, that sounds really easy, but what's that mean? Understand what legal mission constraints I have. The things that you are allowed to do in academic world, you can't necessarily do in an enterprise. So if you want to go scrape the websites for data, that may be okay for you in this kind of academic setting. It is not okay for people to do that when they're acting on behalf of the U.S. Army, right? So we have lawyers, we have oversight people who help train all of our team. And we think really carefully about that because we do have historic, long ago history of people who did not follow those and harmed people and harmed the organization and harmed the mission by not being ethical in their behavior. It's really important. So specifying your method so other people can follow the footsteps. Don't black box your approach. Show your work, right? Clearly lay out the calculated elements and how you got there. Use accurate data visualization. We had a team brief me last week on cost, a cost factor, and they normalized the cost from 0 to 1. And the cost was between $10,000 and $80 million. And so they said 80 million is close to 1 and 10,000 is close to 0. Well, in that factor, that's a great example of something that I care a lot about, the raw number. Don't normalize cost data in my organization, So we had a professional development conversation and they won't do that again. But there's some factors that your organization does not want normalized. So figure out what they are and don't do it, right? There's a really interesting emerging set of problems that we're all facing together about privacy. We all face them as a challenge in our personal lives when our private information is exposed by, for example, Experian. We're all really focused on them. But they're not the only ones. Commercial entities don't have the same restrictions on privacy, or they don't follow the same restrictions. We follow the restrictions, right? If somebody consented to their data being used for a specific purpose and you use it for that purpose and then you combine that data with another data set and use it for something else, we actually talk to our lawyers and talk to our data science practitioners and our data science experts on, is that okay? This is a really big deal when it comes to Privacy Act data that's not personally identifiable information. So if I can discern who you are by your behavior, even if I don't know your name, your social security number, and your address, I need to go talk to somebody before I do the analysis to see is there a way I can respect the privacy with, even though I'm doing a non-PII, in the jargon, analysis. If I'm going to expose a population to scrutiny, that's one thing. If I pivot from the population to taking action that affects one individual, wait a minute. We need to think real hard before we do that. Population-based analysis to see the health of the community, that's good. That's in our mission space. Pivoting to an individual, be worried, right? Practice safe computing on that one. There's a really good MIT website on that that's called the Transparent Accountable Data Mining Initiative. And Tim Berners-Lee was involved in that research. A little bit old research, but it's really useful as you think about some of those privacy concerns about linked data sets. Okay, so where are we going next? Most emerging data is not structured. That means graph analytics, that means other techniques that we're talking about. Gets interesting. Don't use a statistical analysis that's applicable to a small data set on a big data set, right? Be careful. Thinking about sparse matrices, that's interesting. Thinking about set theory, thinking about natural language processing that handles anomalies like humor, parody, double negatives, different uses of the words by different communities, slang. There's some really interesting areas, and when you're working in a well-curated area like published documents in a particular discipline, you can do real goodness there. If you're doing it broadly speaking, like across the Twitterverse, careful, right? And very high dimensional statistical analysis. If you can do correlations with 28 entities in a column for 1 million rows, that's interesting, right? Most of the statistical analyses can't handle big data, so we're interested in that pushing, right? And we want to have analytic approaches that understand and explicitly show where you have uncertainty, right? How do you handle uncertainty? How do you handle new data? And how do you team? Those are the 3 core things. We want to do multi-analytic exploitation of the same data set. If you have a geo and a time, that gets really interesting. If you can link those to entities like people, that gets really, really interesting. If you can link people and objects in networks like we were talking about in the pharma world, that gets really interesting. Not just to see what's connected, but to see if you can figure out, and you may not be able to, but can you understand what's not connected, right? There's really some interesting spaces. Machine learning, deep learning, show your work, right? And we think that new tools and techniques are emerging constantly, so we're pretty excited about that. Okay, so what are your questions about what I've been talking about? I'm turning it over to you. Got something, Greg?
I know students are, like myself, are probably always looking for projects. Is there anything that you've seen that you're not happy with that you're being presented that maybe students could take another look at?
Yeah. It's not that I'm not happy with it, but it's that I'm aware of the incredible diversity of emergency response projects that frequently are very much in the rearview mirror of the crisis. So my example there is that after Hurricane Katrina, there was some really phenomenal analytic research that went into it, but it took 2 or more years to receive the results of that analysis. That deep analysis is important, but that rapid response analysis that works with local EMTs or local disaster recovery operations, I think is really an underserved need that could really benefit, right? But you can't show up the day after a crisis and say, hi, I'm a data scientist, I'm here to help. You have to have some kind of relationship with the people who are going to do the response. So I think that there's a real opportunity there. I'm also interested in watching the evolution of the data science consulting projects because I think that they have opportunity to have tradecraft, good ways of solving problems together emerge and be shared. That'll take time, so patience is also our benefit there. But the rapid response projects I think are really exciting and really needed. Yeah, good question. Somebody back there have a question? Yeah.
So the first and foremost thing which I get in my mind when I'm thinking about army or something is classified dynamic symbol and so how seriously is data taken here? How seriously the privacy of data is taken here? Because on the other side we have the commercial organizations where yes, the data is important, but that is generally crowdsourced. So people like Amazon or Facebook, the data is generated by you and me. But in this regard, the first question which I have is, obviously data has lots of gravity associated with it. And the second question which I have is regarding the disaster management and emergency response. So how the Army is collaborating with the national weather agencies, wherein they have better prediction, or how is the Army trying to get the advantage of the existing knowledge of the forecasting from the weather agencies in order to get better situation and handle it?
Okay, 2 great questions. I'm going to answer them in reverse sequence because, weather. Okay, we are consumers of other people's prediction models in the Army. So the Air Force has more people who are involved in the local predictions, right? But the National Weather Agency, NOAA, and some of the other players, they are the experts. They have the mission to define weather. The problem gets significant when you have the difference between the large-scale weather predictions, which we count on and we consume, and the local area weather, right? As we see it when the TV cameras or the video cameras shine on places like Houston, where the big picture is, oh, the big storm is going to go like this. But your local micro weather is different. But we don't do weather as a producer, we do weather as a consumer. So we're careful to understand our role. We cannot solve every problem in the world because we have lots of problems that we focus on, right? So understanding who we partner with, and weather's really interesting because it's not just here in the United States. We have, as I said, soldiers all around the world working with partners. But you have to understand who in the partnership chain is doing what and be collaborative and respectful of those different missions. Okay, and then the first part of the question you asked was, do we take privacy seriously? We take privacy a lot more seriously than commercial entities because we have a lot more laws. And we have a long history of governing it and making sure that people are trained and certified to respect privacy. And if they violate it, there's strong punishments. That's not the case in the commercial sector. And so as we watch the Experian case being so highly visible, we as citizens and as members of the community that are affected by them will learn a lot about how our country responds to a corporate entity and how they protected privacy or did not. So that's interesting. And then the third part of the question, which you got to when you said Amazon lets us crowdsource their data, they're great at crowdsourcing their little public data sets. They will not let you see their enterprise data, right? They have authoritative data that they manage that incredibly successful business on that we don't see. And it's not clear to me that we will see it, right? That's how business and how business like enterprises like ours work. There's stuff that we can share and there's things that we can't share, and we just need to know where we are when we're having those conversations. Those are great questions. Yeah, Tom.
We have a question online.
Oh, yeah.
Often Army units, especially the brigade and above, have substantial embedded analytic capabilities, such as intel or logistics. Are there any initiatives to partner with those units and enable or improve self-service data science?
Yes, there are. The data science research project that we did, that I described with our ORSA population, our ORSA officers are those ones who are embedded with those units. Some of them are logistics officers, some of them are intelligence officers, some of them are operations officers, some of them are cyber officers, and so on. And so when I say we are doing data science with those ORSA officers, being able to use a centrally managed asset that they can reach from at least the United States locations, that's our data science pilot on our Amazon instance, that's where we're trying to make it possible for them to be able to do that kind of self-service data science. And it's actually been very successful in the unclassified space. When we get to the authoritative data, you can't do data management of authoritative data without proving it's cyber secure. And so we go through a rigorous process, and that's our organization's challenge. You know, we've been working on it. We're getting ready for kickoff on Monday. We're excited about it. But being tested on how secure you are is always daunting, right? So we will learn more. That's a good question. Thanks for whoever asked that.
One last question. I see that there's lots of intelligence or technology or resources pumped in order to make Army a better place, right in the internal or the external sides. So are there any plans to extend this to the allies or to people who, other armies or friends of American armies or something like that, you can extend and share the information which we, for example, like humanitarian reliefs or collaborations and other stuff?
So that's a really interesting nested set of questions you just asked. When we're doing humanitarian rapid response, things that were previously classified become shared openly. And one of the really breakthrough opportunities that we saw this in was in the earthquake in Haiti in January 2010. The satellite images that had been stuck on a server that couldn't share with the outside world were rapidly declassified and shared not just the big data sets, but shared as small shareable JPEG and other small format images so that people who needed that information, when it was approved by our national authorities, remember we have a president, we have Congress, we have a whole leadership thing, but when we get that permission, we shared it very rapidly. We have personalized, tailored relationships with each of our allied forces all around the world in different situations, and so our data sharing with them is according to those mutually negotiated agreements. It's way more complicated than we can even imagine, and we have people who focus on that, who do data sharing, and who do the diplomatic agreement relationships. And we work closely with State Department and some of our other partners there. But when you see our allied relationships like our NATO partners or that kind of relationship, those partnerships are deep and broad and involve that data sharing and sharing those analytic capabilities as well. Yeah, good questions. Anybody else?
But most of what you talked about is like external and operational aspects, but your slide about updating to cloud-based made me think about, is there any movement towards updating the legacy internal systems, the personnel systems that don't communicate to each other, tiers, things along those lines?
Yes.
We're doing really well on one front, but not necessarily looking internally.
Oh, no. Think of it as a handful of sticks of spaghetti before they're cooked. Yes. There are many, many different strands that are all moving forward. Different times, different internal groups that are working that. And so for us, we're moving a variety of the business end systems to the cloud with part of the cloud move that I was talking about. The Army is moving its internal personnel management systems. They're modernizing them to more modern IT infrastructure, and then they're hosting that IT infrastructure in cloud computing. So to modernize, you have to modernize the bucket that you put it in, and you have to modernize the system that you put in the bucket, right? So doing both of those moves at the same time is hard, very hard, very, very hard, but worth doing. But it takes time because you can't stop keeping track of the people that you have and how much you're paying them and the specialty pay and their family members and their family members' medical status if there's a concern like a family member who needs special medical care. So you can't stop and turn the switch on the new one. You go through this stepwise process of flowing all the data in the old one, moving to the new system, proving the new system out, and then turning off the old one after you've proven the new system out. And so, for example, our personnel system for our military personnel is called IPS-A, and that's going to be proven out by the end of fiscal year 2021. So another 2.5, 3 years, right? But they have to keep the current operation going while they move to the new, and that's hard, right? But it's worth doing. Yeah. So, sir, you had a question.
Yeah, I was just wondering, I mean, you talked a lot about the sort of reactive part of the disaster recovery, and I was wondering about sort of the predictive or proactive component to that.
Yeah.
You know, because I mean, some of the things, I'm sure the Army has a lot of expertise in sort of scenarios and modeling and things like that, and I wondered if that extends to the disaster domain or that's a different part of the government.
No, that's actually a great question. We were talking just before this about our National Guard partners who are part of the Army who practice disaster response operation every single year. You know, they do tabletop exercises where they get in the classroom or in the study room and talk with their partners, and then when it comes time to fight a wildfire or respond to a flood or go do some reaction, they're not going cold. They've got those relationships, they've got those analytic approaches, they've got that data sharing set of agreements. Turns out that part of it, we can predict that there will be a disaster. We don't know what the nature of the disaster or the degree of it, right? So we're terrific at predicting part of that. We don't even approach predicting the preciseness of it. And so what we in the Army do, Army, National Guard is part of us, and reserves are part of us, right? Those components plan to be ready to respond to multidimensional disasters all the time, right? As part of our go to war mission, right? We're going to go somewhere where the infrastructure doesn't work. So let's have generators, let's have water purification units, let's have meals ready to eat, those prepackaged meals. Let's have supplies of water in containers. Let's have supplies of fuel that we're ready to put on a plane or put in a truck and send somewhere, right? And so we actually, that's why the 911 force in this country right now is the Army, right? That's why your National Guard is out there helping people in all those places because we practice going to bad places that we didn't plan to be. And then it doesn't matter what your mission is, you have to support yourself and help the other person, right? So in terms of predicting precise disaster, no. In terms of predicting that we will be responding to disaster, heck yeah. Yeah, great question. Yeah, thanks. Anybody have anything else? Good. You all have been very generous with your time, especially on a beautiful Friday afternoon at this university. Appreciate you spending time. Thanks to the folks online for dialing in. Appreciate that too. And that concludes my discussion. Thank you.